Okay, so welcome back. Okay, so here's where we're at. So let me, oops, I forgot to erase this. So we erase all this. Okay, so now, so remember what we did. So we replaced this with 2x1, okay, because of the midpoint formula. Now, the only thing is this thing. Okay, so now, what do you notice about this thing here? We've got x2 squared, and we've got x0 squared here, and we've got double the product of x2 and x0. This you should recognize as a perfect square. So if we rewrite this as this, and now, look at that. This we can replace with x1. And now we've got another equation, right? So now we've got another polynomial here that now in terms of x1. Okay, so now okay, so let's see what we have here. So we've got, let me rewrite this. So this is going to be a x1 squared plus four b x1 plus 4c okay. So now we're almost there. So we've got this here. We just need to figure out how to make this into f sub x1. That's the only one we're missing, right? So it looks like we can get an f of x1 out of there, but it's not quite there because we still have, we've got A, we've got 4 B's and 4 C's. So we can pull this off, but let's see what happens with the rest of it though. Okay. Oh, by the way, this is going to be, oh, hold on. That's where I made a mistake here. This should be a 2x1 squared. There we go. That's what I missed. Okay, so let me start over. Okay, so this gives me, oops, x2 plus x0 squared, because it's a perfect square. This is 2 times x1. That's where I made a mistake. forgot the 2. So this is 2x1. And so it's 2x1 quantity squared. So this becomes a times 2x sub 1 squared plus 2b times 2x sub 1 plus 4c. And now this gives me a 4x sub 1 squared, right? So this gives me 4a x sub 1 squared. This gives me a 4b x sub 1, and then plus 4c, and then now all I have to do is factor out the 4. And so my final result becomes f of x0, I'm going to rearrange things, so f of x0 plus what? 4 times f of x1 plus f of x2. Okay? Now that's the result just for the first 3 points. Okay? Okay. Now, what about the next 3 points? What if we go from x2 to x4? Well, we're going to get a similar result. So if we go from x2 to x4, what are we going to get? We're going to get something very similar to this. Okay? So I'm not going to do the whole thing, but again, you see the pattern comes out to be the same. So if I do an approximation for, so we know the approximation from 0 to 2, or excuse me, x0 to x2 of f of x dx is approximately equal to this. Okay, now, if I go from 2 to 4, I get something very similar. I get right? So now, here's the end result. Now what we're going to do is we're going to add these, right? So what happens when we add these? Because now we're going to get the result if we do, let's say, 2 intervals, and we combine them, we want to go from x sub 0 to x sub 4. So of f of x dx. So that would be approximated by adding this plus this. Well, if we add this plus this, we can factor out the delta x over 3. And now we're just going to add these term by term. So we can add these two, right? So what happens? Well, when we add this, we get this. We get f of 0, x of 0, plus f of x of 2, which is double, so 2 times f of x of 2. And then what about f of x of 3? Well, f of x of 3 is 4. Or excuse me, oh, I skipped one. Sorry. This should be 1. Skipped one. The next one after 0 is f of x of 1, which is 4, right? There's 4 of those, so we get 4. Right? And then after that, we get 2 f of x sub 2's, right? And then the f of x sub 3's, well, there's 4 of those, right? And then the final one, x sub 4, there's only 1. And now you see the pattern. So notice that it starts with 1, ends with 1, and in between it goes 4, 2, 4. Okay? And this is the pattern, so it continues on. If we went to another one, you would end up with 4, 2, 4, 2, 4. Okay? So again, every time you expand this, the pattern will continue on. So this is Simpson's rule. Okay, so next time what I'm going to do is I'm going to introduce the theorem, but this is the derivation for it. Okay, have a great day.